Hello, everyone. My name is Kevin. I'm a sales manager at ZENRIN Europe. So for our presentation today, it will be divided into two parts. And for the first part, I would like to talk about NDS.Classic update region in Japan, specifically focusing on the key challenges our team faced when developing the update region, as well as the approach they took to address those requirements, and of course, the final implementation results. I also like to touch on some points regarding production implementation and suggestions from our team for potential NDS improvements. Now, I do apologize in advance because this presentation might not be as exciting as NDS.Live, but all right. Let's begin with looking at the key challenges our team faced during the development process. So there are four major challenges due to Japan's unique conditions, as well as map characteristic and specifications. Number one is the lack of direct correlation between road and address. I think many of you may know this. Japanese address is not associated with a road, unlike many Western countries. Instead, Japan takes on a block-based address system where the address is associated with a geographic area. And with no correlation between address and road, our team had to implement custom logic to determine which region to assign a certain road to. Number two, non-addressable geographic features. Some features such as ferry routes and sea areas simply does not have any associated address information. And without that, address-based region assignment is not possible. In that case, our team again have to implement custom logic, an alternative method to assign those features to the proper region. Number three is the cross-region feature handling. Some features naturally span across multiple regions. For example, POIs and addresses might have arrival point in one region and a representative point in another. And for those who's not familiar, arrival point simply means the point on the network that is closest to the entrance of the destination, or the point on the network that is most suitable for a vehicle to stop when arriving at a destination. And representative point simply means the center point of the destination. And other features, other cross-region features include highway mode, junction view, link-to-link restrictions, and destination guidance. All this requires special handling to ensure region border consistency. Number four is Japan's specific content. Fitting Japan's specific content and specification into NDS standard requires additional effort, especially when those content is not defined or not defined the same way in NDS. Some examples include toll cost information and highway mode. And in terms of highway mode, I understand this is not a general term. So highway mode essentially is the upcoming event view where it shows the upcoming exit junctions or service area on the expressways. Now let's take a look at the approaches our team took to address these requirements, starting with region assignment based on address data. So when address data is available, things are relatively straightforward. We use address data as a primary key to assign different features to regions. And by using this method, we're also able to handle cross-region features without any omissions. And we can, of course, rearrange the region when needed. But when address is not available, things gets a little complicated. Basically, we use spatial coverage, meaning that we calculate how much of a feature falls into which administrative area to determine what is the proper region to assign that feature to. And if no administrative area is available, for example, sea areas and ferry routes, we simply use the nearest adjacent address for assigning that. And of course, assignment logic consistency is also maintained between upper and lower level, meaning what is assigned to region X in level 12 will also be assigned to region X in level 13. Moving on to cross-region feature handling. Some features are quite straightforward and does not require any special handling. That includes link-to-link restrictions, junction view association link, destination guidance, arrival points, junction view, address name. But some features require special handling to comply to NDS specifications. For example, toll cost information. In a nutshell, what we did was we did not create any virtual toll booth at region border. Instead, we duplicated the relevant information across all relevant regions. And then there's the highway mode where we stored in alignment with POI storage structure. And here is the implementation result. So at the end, we split the 47 prefecture in Japan into 80 regions. And of course, the upper level tile and CRS are all assigned to their respective regions. And the max amount of regions for a single prefecture is 7, which occurs in Tokyo. Now, Tokyo is not large in terms of area, but it is very content heavy. So in order to make the region size manageable, we had to split Tokyo into 7 regions. And at the end, the average data size was about 153 megabytes. And on the bottom, there's a table showing the advantages of updating using update region compared to a full data update, for example, cost, time, etc. But I will not be going into details today. Lastly, I would like to talk about some key points for production implementation and share some suggestions from our team for potential NDS improvements. For production, we understand that flexibility is important. So our region update is developed in a way where the region can be merged or further divided based on customers' requirement. And we also implemented a few measures to support long-term stability as well as adaptability over time. One example being managing unique ID for various features to ensure cross-version compatibilities. So some of the key features include road, address, toll booth, IDs, and the next one is fixed address mapping for region assignment. This is particularly useful when dealing with municipal mergers, which is not uncommon in Japan. So with this fixed address mapping, we're able to maintain the original area of the region regardless of the administrative change in the real world. But of course, we can also change the region based on what is happening in the real world. And number 3 is the fixed region assignment. And basically what this means is what is assigned to region X in version 1 will still be assigned to region X in version 100, just to keep everything stable and consistent. And lastly, for volatile content such as POI categories, structure, and POI attributes, we took measures to ensure stabilities. And to wrap things up, I have a few suggestions from our team for potential NDS improvements. But I think based on Fabian's presentation, I think it's safe to say that not much changes will be made to NDS.Classic moving forward. So number 1 being the expansion of NDS specification, specifically the flexible attribute. Our team felt that the global feature ID, the use scope of global feature could be expanded to support features like arrival points and multi-link to link restrictions. And number 2 is the addition of test case in validation suite. For example, adding a test case which validate gateway ID alignment between links on upper and lower level tiles. And the last one is actually about database inspector. And again, based on Fabian's presentation, this is probably not going to be updated anymore. So I guess I will ask the team to look into the map viewers. Yes. Thank you very much. And that concludes my presentation. And for the second part, I would like to pass it on to my colleague. But wow.
Yeah, just, I mean, the validation suite is probably more topic for Andre Heinisch, who is not joining here today, but we can forward. Anyway, now we have the biggest technical challenge for today. We had on-site presentations, we had remote presentations, and this is going to be a joint presentation. So the plan is first to have Olena back again on the screen. with another presentation she's going to share. So I see you already, but
and can you see the presentation?
Yeah. So the presentation is shared. Then, I mean, for questions on your presentation, we do it together, or maybe there are questions right away. Yeah. Yeah. So if questions come in your mind, you can still address them later, and you and your team is around anyway. Good. So we see Olena. Olena has the presentation. The point here is that the main part of the presentation will be done by Olena, if I'm right, but the introduction will be given locally here by the colleague of Olena. I have to look up the name again because he was not yet on the agenda. Motoyasu-san, right?
Yeah.
Ah, welcome. So you start and you tell Olena when you want to switch slides. That's the process. Thank you.
Hello everyone, my name is Motoyasu, and I have been working on the development of NDS.Live at ZENRIN. At first announcement, we have prepared the pamphlet at the front entrance, so please feel free to take one home. Yeah, and this presentation, at first, I'd like to introduce the evaluation service released by ZENRIN. And next, I'll hand it over to Orena-san from Intellias. She will introduce the Japan map dashboard. What's the next page, please? Okay, the first page is the launch of the NDS.Live evaluation service on the NDS.Live portal. It is with great pleasure that I make this announcement. And with ZENRIN Maps as a part of the NDS.Live evaluation services, we are providing access to our high-quality, up-to-date map contents. Next, please. Okay, next page is ZENRIN data for NDS.Live evaluation service. ZENRIN has been involved in navigation map development since we joined the Physical Storage Format Consortium in 2004. Starting with NDS.Classic, we have released numerous navigation map data in NDS format over the years. We began developing NDS.Live at the end of 2021, and through this evaluation service, we are making road and lane network along with their associated attributes available. And this release focuses on a limited area within Tokyo. The road content covers approximately 64 square kilometers, and the lane contents around 4 square kilometers. Next, please. Okay, next, let us look at the road contents. This is our road data fully converted to NDS.Live format without any thinning or simplification. The road data includes road geometry, as well as key attributes like road type, speed limit, number of lanes, and traffic regulations. We've also added slope and curvature information, which can support use cases like route guidance and fuel consumption estimation. Next, please. Okay, lastly, let us look at the lane contents. A lane is represented using lane groups. Each lane contains information regarding its source and destination connections. Similar to the road contents, lane contents includes attributes like speed limit, directional restrictions, and so on. Additionally, slope, curvature, and elevation data are also included, making it useful for high precision routing. Yeah, actually, I'd like to introduce the evaluation service, especially lane contents, more and more. But unfortunately, I have only 3 minutes for this presentation. So finally, I explained it in the short version today. But Finally, what I want to say is let's sign in the developer portal site and let's confirm our evaluation service data. Then, if you have any questions, please contact us. That's all, and that concludes my part of this presentation. Thank you so much. Okay, Orina-san, I'll hand it over.
Thank you. Thank you very much, Motoyasu-san. These are the great news that any NDS user can now evaluate real Japanese data, and especially HD content is always valuable for evaluators and for everyone. So thank you very much for ZENRIN for this opportunity. And whenever it comes to map evaluation, there is always a question of gathering map statistic. I think that this audience perfectly knows that whenever you are testing maps, whenever you are compiling maps or using maps, you need to gather map statistic. And it was raised on the working groups meeting in Eindhoven recently that it would be nice, it was raised by Tom, I guess, it would be nice to have some map statistic tool for NDS.Live. So today I'm glad to announce that we will be presenting our map statistic framework, and to grab your attention, I will disclose that we are going to contribute this tool to the community. So any NDS member will be able to evaluate and use it for your purposes. And ZENRIN kindly provided us the data for Japan. So this is a full SD Japan map and even few tiles of HD content as well, so that we can chase the rabbits and we can present our map statistic framework and we can give you an overview of the Japanese data to complement the evaluation service release. Map statistic framework. So why is statistic important? It is used to evaluate the map. It can be used to compare map between two formats. To compare a map between two providers, if you need to choose one, for example. To check the attribute coverage. So how many roads you have and how they are covered by the attributes. To compare map version and set up some quality gates, and to detect some anomalies, because you can always perform some logical checks of the quantity of the attributes to understand if there are any anomalies in the map. But it is always challenging due to a variety of data formats. If you're converting map from one format to another, it's always challenging to compare those maps and how the output results corresponds to the input one. The second one is the performance. It's a resource-consuming task to collect the statistic, and always how to visualize it on the map. And for NDS-specific challenge, that you need to collect all feature attributes from different layers. As for one link of the road, all the features are distributed in different layers. We came up with a solution that we need to develop some framework that will have service architecture. It will have modular approach, and we have to define some internal model so that it can be used with the different input map data formats. And so we are using GeoJSON here. Then data should be indexed, and we are using, again, Elastic database for this. And the Elastic family of products and Kibana allows to build interesting and comprehensive interactive dashboards on top of the statistic. High-level architecture. You have input data formats, and you need, first of all, to convert this using some data adapter to the internal model of the framework. Then the data is indexed and stored in the version statistics storage into Elastic database. Then it gives the opportunity to build time-lapse view, detect anomalies, track the regression, and build the interactive dashboard. And all this part, after the data adapters, it can be customized to your purposes. And now having Japanese map from ZENRIN, the full Japan SD map and few tiles of the HT data. So I will share how the dashboard looks like and what coverage of attributes we can check using this statistic tool. So this is the main screen. We have a list of dashboards, the common dashboard with all the features count, and one dashboard per each feature. So we have lines, we have points, and we have polygons. And the interesting one, the range attributes dashboard that allows to visualize the range of the link on the map. We will take a closer look into it as well. So let's start with the common dashboard. It visualizes all the features on the map. It takes some time to load, but you see the points, lines, and geometries. We have the total count of records and values of feature types, and the different pie diagrams, other kinds of diagrams that you can build to check your attributes. This board is not that informative because it's all mixed up here, but for example, for intersection, we can check here that we have connected roads and Z-level attributes, and we see the same quantity here, which already means that all the intersection, they will have connected road attribute and the Z-level attribute. Now the lines dashboard, it is the most important one for navigation. It allows this dashboard to filter by feature type, to filter by version if you have several versions, and by attribute key. For lines, it counts the lengths of features, so the total lengths, the maximum lengths, minimum and average, and count of features with different diagrams as well. Now, for example, I want to check roads. What is the total length? We see 1.627 millions of kilometers of the roads overall. And now I would like to check the ADAS attributes. For example, the curvature. What is the coverage of the curvature for the full Japan? We see 1.604. That means that almost all of the roads in the map are covered with the curvature attribute. Now let's take a look into the lanes. We can choose lane and it visualizes the tiles with this limited area with the lane content. And we have as well length, maximum, minimum, and average. We see that there are no lanes with the 0 length value, which is good. So, and now the points dashboard. We have point features, the total count of it. There are actually 4 features for the points. And this dashboard also provides some values for top 3 values of feature properties. So you can see what is the most popular value for Z-level, for name, phone number, opening hours, or parking facility size. It also can give you insights to evaluate the map. I will skip the polygons dashboard. This is just the geometries, not much interest, so let's maybe spend time on the range attributes better. These are all the range attributes visualized on the map, and for example, I will select the railway crossing. It is usually assigned to a range of the road that intersects on the same level with the railway. And we see that we have part of the link highlighted for the range that is particularly defining the railway crossing part. So this is it in a nutshell. So as the next steps, so we want to implement the difference, visualizing the difference between map versions to be able to test where exactly you see the difference between maps. And The second step is a map matching to be able to compare two maps of the different formats to visualize this difference exactly on the map. And we, as I already mentioned, we want to contribute this tool to NDS community, so stay tuned and hope you will enjoy it. Thank you very much.
Oh, thanks, Olena. People are clapping hands again, in case you cannot hear.
Okay.
Questions to Olena? It's a last opportunity, by the way. She won't join for dinner. Pretty sure about that. Boris is approaching. You cannot see him. But
Okay.
it's him. Yeah.
Thanks, Olena, for the presentation. Quick question, when you say share the tool, so it's just the dashboard, or maybe you can also open source it so that people can add their own fields or whatever they need to view?
Yes, we will share the framework, so you will be able to customize it for your purposes and use it, right, and build your own dashboards on top.
All right, thanks. That's very good news. Thanks.
Yeah, thank you.